Okay, nice friends. Here we have exponents to deal with. Are we there? Good. We are given that 27 raised to the power of x, an exponent, and we have 3 raised to the power of what? The roots of x, an exponent as well. Are we there? Good. Here is the cube root of the whole of the term. Very good. How did we get the value of x here? Okay. The very first step we have to observe here is to check if there are further ways we can simplify either the term on the left or on the right. Does this make sense here? Good. We might end up, of course, doing a comparison of bases. Are we there? Here we have the base of 3 and here we have the base of 27. So I can express 27 to a base of 3 to give me what? 3 raised to the power of what? 3. Are we there? Good. Then I introduce my x. So this term here is the same as the term above. Does this make sense? Very good. And what about to the right? To the right, what can I do? I have 3 here, so I can write my 3. Okay. As one of the laws of indices. Look at this. The cube root sign here, if I have the cube root of x, like this is the same thing as what? X raised to the power of 1 upon 3. And we do that here. So here I have 3 raised to the power of root x, all raised to the power of what? 1 upon 3. Does this make sense to us? Okay. At this time, what else can I do? Good. You observe that I would have to multiply the indices here. Since if I have a raised to the power of m, all raised to the power of n, this simply simplifies to give me a raised to the power of m times n. So I will adopt that here. So here I have 3 raised to the power of 3x to be equal to, are we there? 3, raised to the power of, now root x, I can decide to still make it x raised to the power of 1 upon 2. Then by the time I multiply it by 1 upon 3 here I have 1 upon 3. So that at the end of the day, I'll be having 3 raised to the power of 3x to be equal to 3 raised to the power of x power 1 upon 2, then upon 3 here. At this point, we have made progress. Good. So we have simplified the complexity of the original question, right? Very good. All we need to do here is to understand the fact that since we have common bases, are we there? Good. Of 3, we can do what? Compare the indices. So comparing the indices now, we have 3x, the index here is equal to the index here. Are we there? Very good. 3x is equal to x, power 1 upon 2, everything upon 3. So to simplify this further shouldn't be a problem, of course. So we can have 3x multiplying 3. This will give us what? 9x to be equal to x to the power of 1 upon 2. We are done solving. All that is left is further simplification, right? Very good. So we can decide to collect the like terms. Here we have x and we have x here, right? Good. So it means that I can have x, by the time I divide both sides by this, divided by x raised to the power of 1 upon 2. This is equal to what? 1 upon 9. So I divided both sides by x raised to the power of 1 upon 2, goes here, and then divide further by what? 9, and this goes this way, right? So here now I have x raised to the power of 1 upon 2, applying the subtraction law, the division law of indices, right? This is power 1 here. So 1 take away what? 1 upon 2 will give me 1 upon 2 here, right? Very good. So here I have 1 upon 9. So that at the end of the day, we get the value of x. There is 1 upon 2. The inverse of this index here is 2 upon 1. So x, raised to the power of 1 upon 2, I square both sides to equal to 1 upon 9, squaring both sides. So that at the end of the day, this eliminates this order, and I'm left with what? X to be equal to 1 upon 81. Does this make sense to us, friends? Very good.